Hello and welcome to Aspire Civil Studio. In this video, we are going to perform the slab reinforcement detailing in the Staad RCDC using our structural model of Etabs only. So let's start.
So in order to design the slab in the Staad RCDC, first of all, what we have to do is we have to take certain data, like for the design data, we have to just import it into Staad RCDC, right? So for that, make sure the model is locked, okay? Like you should have analyzed the model, then just go for the file section, then go for the export. And here you have to select this third option, which is Etabs database table to access, okay? This access files only, you can just import it into Staad RCDC. So I will select that. And here what you have to do is we have to select the model definition and the analysis result. We don't need to select the design data because we are going to design the reinforcement in the Staad RCDC only. So we don't have to select that. So once you select this, you have to just select all the load patterns like the earthquake loads, okay, dead loads and live loads. Okay, everything you need to select for the load patterns. Then after load cases also you have to select, and load combination also, all this load combination you have to select, and for those loads combination only you have to design the reinforcement, right? Then after you can just click on OK. And once you click on OK, it will take a lot of time to just convert this ETAS file into access file. Depending on the configuration of building, it will take a lot of time. For this G+2 building, you can see the area is very less. Even the area is less, it will take at least 4 to 5 hours to get completely converted into access file. So to save the time, what you can do is you can just export any particular floor, okay, that you want to design in the Staad RCDC. Let's say I want to do the reinforcement design for the second floor only. Okay. So what I will do is I'll go for the file section and then export. Here I will select this option, partial Etabs ADP file. So here I'll select this option as we are going to design the second floor only. So I'll select the second floor here and then OK. And then after you can just provide any particular path here. Let's say here only I will save it, second floor and S. The second floor file is exported. Now what you have to do is you just have to open the Etabs. You can just export a whole structure into the access file also, but it will take a lot of time. So what you have to do is you have to convert it into the partial Etabs file. Like you have just have to select the particular floor that you want to design in the Staad RCDC. So as for now, we have just taken the second floor that we want to design in the Staad RCDC. So it will take very less time to just convert it into the access file so that we can just import that access file into the Staad RCDC. Okay, so we will open that second floor, this one only. Now, if you go for the 3D view, you can see this is the second floor and this is the first floor. So as of now, there is no joints on this here at the column joint. There is no joint basically. So what you have to do is, first of all, you need to assign the joints here. Okay, if you don't assign the joint here, the Staad RCDC will show you some kind of error. So to avoid that error, you have to apply the joints like the fixed supports. Okay, and once you apply the fixed supports, take the mesh size of, let's say, 0.5. Then just analyze this floor. So you can see this one is analyzed. Now what you have to do is you have to just export it as a access file. Okay, so we'll go for the file section and export, and here we'll select this third option, Etabs database table to access file. Okay, now we have here the second floor only to just export it, and here we'll select the analysis result and the model definition, and we'll select all the load patterns. Okay, all the load cases, and then all the load combinations, right? Then after, just click on OK, and here you have to provide length units. Like the dimensions here are in the meter only, so here length unit you have to take as a meter, and the forces unit always you have to take it as a kilonewton. Okay, temperature you can take anything. As of now we have not applied any kind of temperature load here, so you can select any particular according to your preferences. Then after, just click on OK. Once you click on OK, the file will be converted into the access file. To convert the one floor only, it will take at least 30 minutes. Okay, and to just optimize it so that you can open it into like in the Staad RCDC, it will again take like 20 to 30 minutes. Okay, so for the one particular floor, it will take about 1 hour. So I have already exported this particular file into access file, so I'm not going to select that particular option. Now I'll just simply open a Staad RCDC. Okay, and here I'll just select the RCDC and click to accept. Then after, what you have to do is you have to provide the project name, client name, and the engineer name. Okay, you can provide it anything. Okay, and you have to just provide the design code. Okay, so we are going to use IS456 and IS13920, which is the ductile design code. Okay, so we are going to use these two codes for the reinforcement design. And then after, we have to provide the analysis data, like the file that we have exported from the Etabs only. So here I'll click on this option, and let's say this is the access file that I have already exported. So I will select this, and then after, I'll just click on open. And then after, in the design element section, you have to select a particular element that you want to design. Let's say for now, we are going to design the slab only. So here you have to select the levels. Okay. So I will select the second floor only, and then after, create a new project. Here we have to select the second layer because the slabs are there on the second floor only. Okay. On the first floor, we have not taken any kind of slab. Okay, like you can see in the Etabs model, this is the first floor, only columns are there on the first floor, and this is the second floor, and the slabs are there. So we are going to take a second floor here, and then just click on create a new project. So once you import that access file into Staad RCDC, you'll get this kind of window. So here design data is there, and this is the slab layout. So you can see the slab labeling and all here. This is the S1, and this is the two-way slab, S2, S3, S4. Okay, so all the slabs, the span in X and Y direction are mentioned here. Okay, for every particular slab, you can see whichever the slab you select here, that will be highlighted in the red color in the slab layout window also. Okay, then after, a span type is there, like it is mentioned here whether the slab is one way or two way. Also you can change it according to your preferences also. So for now, we'll keep it as a two way only. Then after, the panel type is there. Okay, so according to the panel type, the reinforcement will be decided. Okay, like the curtailment length, that will be decided. You can see here for the slab one, the panel type is two adjacent edges are discontinuous. Okay. Like we can see this particular edge, this is discontinuous because there is no structural slab after this slab. Okay, so this is the discontinuous edge. Same here also, there is no slab here, so this is the discontinuous edge. Then after, here this edge is continuous because the slab is there. This edge is also continuous because the slab is here, S3. So these two adjacent edges, these are discontinuous. Okay, so here panel type is two adjacent edges are discontinuous. You can change this panel type also according to your preferences. What you have to do is just click on the particular slab. Then after, just go for the span type, and here you have to select whether it's a one-way slab, two-way slab, or whether it's a cantilever slab. Let's say this is the two-way slab only. So we'll select two-way slab, and then after here we have to select the panel type. Okay, interior panel we have to select when there is like all the four sides are continuous for the slab. Okay, so interior panel will be there. So one short edge are discontinuous. Let's say if this edge is discontinuous and there is a slab for this particular edge also, so this one short edge is a discontinuous here. So according to that only you have to select the panel type. So here Staad RCDC will also decide what is the panel type. So you just have to confirm it once. For this S2 slab also you can see two adjacent edges like this one edge and this one edge are discontinuous. So the same panel time is there. You can see two adjacent edges are discontinuous. Then after S3 is there, and for S3 this particular edge is discontinuous. Okay, this remaining three edges are the continuous only. So here one short edge is a discontinuous. This is the short edge. Okay, so this is the discontinuous only. Then after S4 also the same panel type is there. One short edge is a discontinuous. This one edge, this is the discontinuous. For the S5, two adjacent edges. Same goes for the S6 also. Two adjacent edges are discontinuous. So once the panel type is decided, what you have to do is you have to provide the imposed load, like nothing but the super dead load only. And then after you have to provide the live load also. Then after you have to provide the thickness of the slab. And then after you have to provide the top of slab, like whether the slab is sunken or is it raised. Okay, that things you need to provide. Let's say the super dead load on this particular slab, like the floor finish load, or you can say the floor tile loads. Okay. This load is nothing but the super dead load. Dead load basically will be automatically calculated according to the thickness and the span of the particular slab. Okay, so we don't have to provide a dead load here. We just have to provide imposed load only, which is super dead load. So let's say 1.5 kilonewton per meter square. That is the super dead load, and the live load we are going to take for every particular slab is a 3 kilonewton per meter square. So I will just copy this load, and the same load I will apply on all the slabs. And for every particular slab, let's say for this S1, S2 slab, I'll take the thickness as 150 mm. 150 mm. Then after for the S3 and S4, let's say I'll take 125 mm. Okay. And for S5 and S6, I'll take 150 mm. Okay. Then after you need to specify whether the slabs are raised or sunk. So let's say S3 and S4, these are the 125 mm depth slab. So for this one, S3 will take as raised by 250 mm. So here I'll provide 250. Then after, let's say this S4 slab is there, which we for now will take it as a sunken slab. So let's say it is sunk by 250 mm. So you have to provide the values in the terms of negative, like minus 250 mm. Then after, the last option is there, is the cutout there or not. Okay, whether the opening is there or not in the particular slab, that things you need to specify. So as of now, we are not going to take any particular opening in the slab. So these are the things you need to specify. Now the next thing you have to do is just go for the setting and then design parameters. Now here in the design parameters, you have to select a detailing style, whether you want to we are going to provide a reinforcement according to the curtain bars or the bent up rebars, right? So we'll talk about this curtain rebar and the bent up rebar. So we'll refer one code, which is SP34 we are going to use. Okay, so here these are the two detailing styles. The first one is a bent up rebar. Okay, so these are the bent ups. You can see the bar is going to bend up here, and the bent up will end here, and this will go into the support. And this is the detailing style for the curtain rebars. So we will see according to the board style only. First of all, let's just go with the curtain rebars. Okay, then after here we need to specify the span to effective depth ratio according to the IS 456. So this value will be automatically taken from the code itself. You don't have to change it. Okay. Then after the grade of concrete, we are going to use M25 and grade of steel we are going to use is FE 500. Then after cover you need to specify, let's say we are going to use a 15 cover, and minimum thickness is for the slab we have taken is 125 right? So we have to specify this value. Then after detailing option you have to specify, like whether you want to just carry detailing using the rebar diameter, or you want to specify the detailing using the spacing. So if you take the spacing also, what, let's say if you take 200 spacing, okay, so the according to this 200 spacing only, the bar diameter required will be decided, okay, by the Staad RCDC, but this spacing will be constant for the every particular slab. Then if you go for the rebar, you can select any particular rebar. Let's say I'm going to use 8 8 bar only, so this same 8 bar will be used for every particular slab, and the spacing will vary for every particular slab. That is the thing. Now we will use the rebar option here. Then after, a curtailment location is there, okay, this is also L by 6, and L by 6 for the bottom continuous end, L by 6 for the bottom end support, okay, for top end support it is L by 4, for the top continuous support it is L by 4. So the next thing we need to specify is a rebar diameter, like 8 10 12 16 20 25 These are the bars we use in the India, right? So all these bars we have to select. Then after, we need to specify the minimum spacing. So 100 and maximum spacing is 300 okay, for the main reinforcement. And we'll take the spacing at the round of 25 like the spacing, like the minimum spacing is 100 then after 125 150 like that, okay. So round off we have to take of the 25 only. Then just click on OK. So these are the things we need to mention. Then after, what I will do is I'll just go to design and then just click on auto design, or there is a shortcut here, auto design, you can use that also. Just click on OK. Okay, all the slabs will be designed according to the thickness we have provided and according to the super dead load and the live load we have applied. So for every particular slab, let's say this is the slab 1 and the thickness is 150 Grade of concrete we have used M25 and steel we have used Fe500. So here for the bottom in the X direction, 8 bar is going to be used at the spacing of 200 and for the Y direction, 8 bar at the spacing of 275 will be used. Okay, this is the top reinforcement. Here you can see for the S3 and S4 slab, we have used the raised slab and the sunken slab. You can see here 250 raised and 250 sunk. We can go for the design output here also. You can see for the S3 slab, we have provided the value in the positive terms like 250 okay, so this will be raised. If you go for the design output, here you can see remark that this S3 slab is raised by 250 and for the S4 slab we have taken top of the slab as a minus 250, so this will be sunk. You can see 250 sunk. So here, as this one is designed, what you can do is to see the reinforcement detailing. What you can do, just go for the report and then just go for the text schedule. Just click on S here. You can get the schedule for the group of slab. Okay, for S1, S2, S5 and S6. For this 4 slab, the same detailing is required. So you can see the groupings there. So 150 thickness is there. Okay, this along the shorter span, 8 bar will be used at the 200 spacing, and along the longer span, 8 bar with the spacing of 275 that will be used. Okay, and this is the top reinforcement for the continuous support, for the end support. Okay, for the end support, and distribution steel is there also. If you want to see the reinforcement detailing, then you can just go for the rebar and just go for the in plan detailing. Okay. So this is the bottom reinforcement layout. You can see this is the bottom reinforcement. If you go for the code, we have used the curtailment design, right? So this is the bottom reinforcement, okay, and this is the top reinforcement. And what we are seeing in the Staad RCDC, this is the bottom reinforcement only. If you want to see the top reinforcement, then here you can see the top reinforcement is there. Just click on this one, and this you can see this is the top reinforcement. First of all, let's just see the bottom reinforcement. So here you can see this is the bar which is spanning in the y direction basically. So it will be 8 mm bar with the spacing of 275. Okay, and this is the bar which we are going to provide along the shorter span. And the details for this particular bar is this is going to be 8 mm bar with the spacing of 200 mm. Okay, and these are the slab dimensions, like whether the slab is one way or two way, and the thickness is also provided. Same goes for every particular slab. You can see this. Now let's see the top reinforcement. Now this is about the reinforcement detailing using the curtain rebars. Now let's see how we can design the reinforcement using the bent up rebar, like for this particular style. This you can see this is the bent up bar style. So we are going to use we are going to design the slab according to the bent up style only. So for what you have to do is, first of all, we need to unlock the model. So here I'll just click and S. Then after we'll go for the setting and then design. And here detailing style for now we'll take as a bent up rebar. Then after I'll just click on OK. And we'll just design the slabs again. Okay, now we'll go for the report and then in plan detailing. You can see this is the bent up rebars. You can see this is the steel we are going to provide in the y direction, right? And the bent up here is going to start at the 920 mm. Okay, for this one, these are the alternate benters basically, and this is the steel which we are going to provide along the shorter dimension of the slab. So this is about the in-plan detailing. Now let's say if you want to see the sections of the slabs. So what you can do is just go for the report and then go for the slab sections. So here, I'll just close this for now. Report and then slab sections. Here, let's say I want to take the section for the 2 slabs. Okay, so number of slab I will take as a 2. Then after a section mark, I will take it as a. Okay, here you have to provide the slab a number. Let's say for the S5, like this for S5 and S6, we are going to give the sections. So here S5 I'll select, then after S6 also. So let's say we are going to draw the section for this S5 and S6 slabs. Okay, and we are going to just see the section along this longer edge, you can see, according to the plan here. Now then after the edges you have to select whether you want to cut the slab along the short edge or the long edge. So you can see this is the long edge basically, right? So you want to cut the slab along the long edge only. So here we'll select long and long here for both the slab. Then after you need to specify the left support type. You can see for this S5 slab, the left support is like end support. As you can see, there is no structural slab here. Okay, so here this is the end support. Then after left support mark you have to provide like B9. This is the beam is there. So number of the beam is B9. Then after width for the left support you have to provide. Let's say 200 mm. Then after depth of the left support also you have to provide, let's say 500 mm. Then after a right support. Now for this S5 slab, this is the right support, right? And this is the continuous edge. So here, this is already considered that this is the continuous edge. So you don't have to change it. Then after you have to provide the mark, which is B12. And width for that one is 200 mm and the depth is 500 mm. Okay. Then after for the S6 slab, this is the left hand. For this S6 slab, this is the continuous. Okay, so this already we have provided. You can see B12 200 over 500. Now we just have to provide this end support only. Okay, so you can see the right support for this S6 slab. This you can see is a B15. Okay, and it is the end support only. So here The right support type is a end support. By default, it will be selected. Then after, a support width is a 200 mm and the depth is 500 mm. Then after, once you provide all this data, just click on draw. You will get this slab sections. Okay, you can see the width of this B9 beam is a 200 mm. Okay, and this is the bent up bar. You can see. Okay, here the bent up is going to start from the end support at the distance of 655. Okay, and here 8 mm bar of 275 mm will be used. Okay, same you can see here also. Now let's say we'll draw the section for this shorter slab. You can see S3 and S4, right? So again, we'll go for the report and then slab sections. Let's say I want to include two slabs here, and I will give it a name section mark as a B. Okay, and here slab I will select S3 and S4. So once you select the slab, the dimension will be taken here. Then after, you need to provide whether you want to cut the slab along the short edge or the long edge. So let's say I want to cut it like this only. So this is the edge we have to consider as a long only, because this you can see this is the long edge for the slab. You can see this in the X direction. Basically, the span of this particular slab is large. Okay, and we are going to cut the slab along this span only. So here we have to consider a long span for the both slab. The left support here, this is the end support. Basically, as you can see, there is no structural slab here. So this is the end support. Then after the left support mark is a B10. Then after width will take is a 200 mm and the depth for the support is 500 mm. And the right support is B13. And this you can see this is the continuous basically. Right. And here then after a left support for this S4 slab, you can see this is the B13. Okay. And for the B13, we have already provided the dimensions. Okay, so we don't have to provide here. Then after we'll go for this B16, which is the right support for the S4. So here, this is the end support basically. So we have to select that condition and the mark we have to provide B16. Then after width is 200 mm and the depth for the beam is 500 mm. Then you can just add it into the existing drawing like this one, or you can just create a new drawing for this slab sections. So you can see this is the S3 slab, which is raised by 250 mm. And you can see this is the floor level. And this is the S3 slab, which is raised by 250 mm. Then after, this is the S4 slab, which is sunk by 250 mm. And you can see this is the bent up detailing for this particular slabs. You can just save this detailing also in the AutoCAD format. What you have to do is, first of all, just save the project. Once you save the project from here, if you want to just take this drawing into the AutoCAD, just click on this option, save. Provide any particular name and just click on save. And if you go for the same folder, you can see this is the DXF file like the AutoCAD drawing. You can open it in the AutoCAD also. So as you can see, this is the file which is open in the AutoCAD that we have exported from the Staad RCDC.
So that's it in this video. Thank you so much for watching. If you found this video helpful, then please like, share and subscribe to our channel so that you can get notified for the videos that we'll be uploading in the future.